Okay, good morning to all of the participants. 大家早上好，可以听到我讲话吗？Okay, so 大家早上好，我是拉曼大学的Dr. Tan Joy San。所以接下来我都会用英文跟大家讲解一下今天的那个课。Okay. So good morning, everyone. Okay, today we're gonna start with the fourth workshop. This is an advanced level. So for today, we're gonna talk about the sorting. Okay, for sorting, there will be four types of sorting that we are going to discuss for today. First is bubble sort, insertion sort, then merge sorts, and quick sort. First thing you need to know that why do we need to know about sorting? Sorting is basically to arrange a set of items into order, either into ascending or descending order, like what we see over here, that it is actually based on here, let's say this is a set of arrays. If some of you know about array, that every array there's a value inside each of the columns. And we are actually trying to arrange it in the ascending order. Ascending order means that from the smallest to the largest. Well, for descending order means that from the largest to the smallest. So what is the purpose of sorting? That you're trying to arrange it from the largest to the smallest. For example, that if you want to look up a word in the dictionary, well, I hope that, okay, some of us is actually using dictionary, because now the dictionaries that we are using probably is e-dictionaries that it is already installed in the mobile applications. But last time, when we still have the hard copy, which means that it's the book. So if you try to look up on the dictionaries, you will try to look up based on the arrangements of the words, right? Let's say from A, B, C until D. So if let's say it is a H, starting with the H letter, then you will know that, okay, follow from A to B and then until the H. So you just go to the H and then you look up the words. That is why you need to have this sorting. So imagine that if, let's say, a dictionary is all alphabets, all the figures that we are looking at, there's no arrangements in it. So how are you going to look into into that whole set of items? It would be taking a longer time to actually look up, because you have to look up into every single of the items. Then only you can get the items that you want. So that is why we need to have this sorting, so that everything is arranged in the order. So how are we going to do the sortings in the array? Since it is something that we need to look up. So even though there's a libraries or maybe some functions that is very simple, you call and then you can make the arrangements, but we still need to know the mechanisms inside that. How are you going to do the sorting? So these are the sorting methods that we will discuss, that I hope all of you still remember about the big O notations, which is the algorithm analysis. For the sorting, it's we're going to talk about the big O notations, as it's going to affect the performance in terms of the times and also the memories. Okay, in this, we're going to assume that the array that we've been discussed all is actually sorted in the ascending orders by default in all the examples. Okay, first thing, let's look into the bubble sorts. So for bubble sorts, it actually takes O(n) squared time in all cases. So this is probably the simplest and slowest way to sort a set of items stored on an array. So mostly, okay, in this workshops, we're going to use arrays to explain on how the sorting actually works. So the basic idea is that we're going to have a bubble that's going from left to right on an array. So the bubble is supposed to contain the largest elements. In each round, compare bubbles, okay, and its left neighbor to see if the bubble has the largest element. So if yes, do nothing since we want to move the largest element to the right, else swap the two neighbors in order to move the largest element to the right. So how it works, okay, let's see some examples. So these are the examples that we are looking at where it is arranged in 23, 78, 45, 8, and 32, 56. Now we want to arrange where 8, 23, 32, 45, 56, and 78. So how are we going to make the arrangement using the bubble sort? The first thing is we're going to check between these two, 23 and 78, compare. Is this the bubble, is it the largest? So if yes, then we do nothing, right? Then we move, okay, we move into the next iterations. It's actually working based on iterations. So first iterations that we go through, that I would check 23 and 78 first. Compare 23 and 78, which one it is the largest. Example here, 78, of course, we know that it's the largest. If it is the largest, then we do nothing because we want the largest one to be kept in the right-hand side and the smallest to be kept in the left-hand side. Go into the next round, move, where you're going to compare 78 and 45. Let's say here, obviously 78 is larger compared to 45. So what will happen is we will do swapping. Swapping means we have to swap the positions between 78 and also 45. Why? Because as mentioned, largest will be kept in the right-hand side and smallest will be kept in the left-hand side. Then move. Okay, move into the next round. For into the next round is the same thing where you do the swapping because 78 and 8, it is 78 will be largest and 8 will be smallest. So you have to do the swapping. So after you swap, we'll see. So this one, it will repeat again and again. So 78 and 32, then you do swapping because obviously that 78 is the largest. So when it goes through every single iterations, you will just keep performing the swapping. So at the end, what we get is we get the 78 would be at the last. So this one, what happened is that you can see the largest one, it has been moved to the right. So after we move to the right, so we consider that the 78 is assorted and the one that is actually in the left is unsorted. So now what we do is we're going to choose the new bubble. New bubble here, assume that we choose the one that is 45. Then same thing where it's going to compare again, which is actually similar to the one that is 78, where it would compare that if let's say here 23 and 45, is it the one that is largest? 45, yes, means that is, but it's in the right, so nothing happens. Then when you go to the next iterations where 45 it's compared with 8, yes, so 45 is actually larger compared to 8, so it would do the swapping. So this one will happen, so 48 and 32, it's the same thing where it's going to do the swapping as well. But then when it comes to the 45 and 56, this one, nothing happens because 45 when compared to 56 is not the largest. So do nothing. Nothing is going to happen over here. Okay, then you can see 56 and 78. This one is already sorted. And now, same thing, that we're going to look into the new bubbles. So for the new bubble here, that if we compare 23 and also 8, 23 is larger than 8, and it is in the left side. So what happened? You need to do the swapping. Then what happened? We move into the next iterations where 23 will compare with 32. That this one, nothing's going to happen, right? Because it is 32 larger than 23, then it will remain in the right-hand side. So move on. Remember that it has to check every single iterations until the end. So you have to know that which part is actually the end of the, for this size of the array. So like this one, 32 compared to 45. 45 is larger than 32, so we do nothing over here. It seems that here, okay, we have the sorted and this one is the unsorted part. So we still need to continue because obviously it's not, is it sorted? Yes, it is sorted, but what happened is that it will still continue because that is what will happen. Even though you know that obviously it's already sorted, but it still continue until the end of every single columns that we have actually gone through. So this one you will still compare that 8, you will still compare with 23. Is it largest? Well, no, so it would do nothing. Then you will go through the next one, compare 23 with 32, so nothing. Is it going to compare again? Yes. It will continue until the end. You can see here we have 8 and 23. So we still compare that new bubble is largest. No, so nothing is really done. Then we'll have the sorted items over here. So that will happen in the bubble sort. So what you can see here is in here, even though that we have already know that this one, okay, based on our eyes, when we're looking into it, we know that it's sorted, but we will still go through every single of the columns until that we're sure that it is sorted. So here we look into the, okay, we look into the codes. So code here is first thing we will go through, okay, we will set the for loop. So this is actually the for loops. And we have nested for loops, where this one, okay, it is the inner for loops. For the outer for loops, what happened is that we set the conditions where n, you can see n is number of items minus with 1. Number of items, so for example here, we have 1, 2, 3, 4, 5, 6. So we have 6 items. And don't forget that array always starts with the index of 0, so we have to minus with 1. So consider here, we will go through 6 items, which means that we're going to have 6 iterations. And then we go into the inner for loops. For inner for loops is j equals to 0 and j less than n. and j plus plus. You can see here, if j is less than n, which means that every time we come in, so we're going to have to go through every single of the columns. From here, we're going to compare. You can see j and j plus 1. So we will compare 23 and 45, let's say in the first iterations. If it is the largest, then we will going to continue with the swapping. So if it is not, then nothing is going to happen. So the complexity would be O(n) of items squared, because normally when we look into the big O notations and do the analysis, if we have a nested for loops, it will be the O(n) squared. So that would be the worst case where we need to go through, I mean, no matter how, we need to go through every single of the items here, and we have to look into and make the comparison. Okay, so there will be one friend is asking that when is the test is going to start. So let me look into. Okay, the test is going to start at 12:30, right? So I hope that I answer your question. So the test will be started at 12:30. So make sure that if you want to join the test, you can choose to come back at 12, maybe 12:20, because there's an announcement that's going to make. All right. Okay, so now we continue. Okay, into the insertion sort. That for insertion sort takes the timing of O(n) is the best case at O(n) squared time in the average and worst cases. Why the best case it would be O(n)? Because if we look into the algorithms here, into the code over here, where if let's say the items is actually sorted, everything is arranged according to orders, which means that we don't need to go into the for loops and look into it. So that would be the best case. But if it is not arranged in order, so which means that we have to go into the for loops and make the go into the for loops and also running all the codes. So that's why we're getting the worst case with O(n) squared. Compare O(n) with O(n) squared. Of course, the times that we would take for the O(n) squared would be greater if compared to O(n). O(n) is linear for almost sorted arrays. So the array is parted into two parts, which is sorted and unsorted. Each time, okay, n items is inserted from the unsorted part into the sorted part. So this one is that you have to look into it. Okay, this one is insertion sort, sorry. Okay, this one's insertion sort. And so the insertion sort is actually in the O(n) squared. But before we go into the insertion sort, sorry, so let me show you what is the mechanism behind the bubble sort, that how it's actually working. So now if you look using this, I'm going to visualize to use that how the bubble sorts works. So first thing, if you look into the codes here, is we're going to use the functions to call out the bubble sorts codes, where first thing, let's say we have these items. We're going to set the size of the array to be size of 6. So we're going to have this 6 items here. 1, 0, 1, 2, 3, 4, 5. Okay, so 0, 1, 2, 3, 4, 5. This is the items that we are looking to. Okay, so this is the array that we are looking to, where 32, 78, 59, 56, and 23, 28. So it's actually going to arrange in this order. Okay, it's arranged in this order. Then we're going to print out all the items in the array first. So we know that array is a reference, considered as a reference parameters. So it's going to refer back. When it is a reference parameter, means that when it call ups in the array, that it's going to refer back to the array that is actually remained in the main function. So that's why you can see the arrow is actually pointed. So in fact, that what you do in the function, it is going to, it's going to pointing back to the array where it is being called. So here it is being called from the main functions. So it's referring back to the array that is actually in the main function. So this array, this functions here is just to print out the elements in the array. Because you see here, I hope you understand what is happening in the functions. Because let's say when it comes to this function, which is in line 16 here, print array. So this is the name of the functions that we gave. ARR. So ARR is the array that is being declared and created over here, which is the size of 6. And the data types for the array itself is the int. So 6 here, we put in the 6 elements that we initialize it. So when it is created, so under the stack memories, which is under the main functions, that we have size of 6, and this is the array where the name of ARR, because we give the name for the array is ARR, and we have 6 columns, because here, the size is 6, we set to be the size of 6, and each of these columns, it has its own value with the types of int. So here first is 32, 78. Follow the sequence 59, 56, 23, and 28. So this one would be the array, that's created. So then when it comes to 16, line 16 here, which means that we call the functions, we're going to pass in the array and also the size into the functions. So when we call the functions, we're going to go into the function. This is the customized functions. We call it as a user-defined functions that is being defined by user. That we're going to use the for loops, to go through every single of the columns here in order to see out what is actually inside the array. So if I click on the next buttons, that you can see here, because the screen that I have here is too small, so that's why you can see all. But what happened is that print array is going to print out every single element in here. So you can see original, 32, 78, 59, 56, 23, and 28. Next, if we go to continue, that it go lines by line, that we go into the bubble sort function. So bubble sort function is the same thing where we're going to pass in the array and also the size. So we go into the next. So this is how the bubble sort functions looks like. So this one, pass in the array and also the numbers of the size here. So for functions, I hope you know that in the function header here, it's not necessary that need to be the same name as the calling functions. It can be a different. So here we have the list and also the numbers of items. So list, basically, it is actually referring to the array in the main functions here, because array is considered as a reference, as mentioned. So is list is actually referring to the array. Next one we're going to look into. So this for loop is the one that already shown to you on the slides here. So same thing, ends where it equals the number of items minus with 1. So number of items we're referring here, you can see it's a 6. N is greater than 0 and n minus minus. So we have n is 5. Why? Because here is number of items minus with 1, which means that it's 6 minus with 1, that n is 5. So if we go into the inner for loops, for inner for loops here, for j equals to 0, j less than n, and j plus plus. J 0, so here we have j is 0. Now we come into the line 44 here. So line 44 here is list j greater than j plus 1. If it is greater, then we have to perform the swaps. So now we look into the list j. So what is the items of list j? So for items of list j, so if we look into j is 0. So is it greater than list? J plus 1 means that 0 plus 1, right? So list 0 is 32. Is it greater than list 1, which is 78? Obviously, it is not, right? So when it is not, what happened is that you can see the arrow. It is not going into and perform swaps. That it will straight away go into the next iterations where it will update the values of j, which means now our j is 1, and it will come into. So in the next one, what we're going to compare is list, okay, with 1 greater than, okay, list 2. So list 1, it is 78. Okay, list 2 is 59. So list 178 is greater than list 2, which is 59, right? So is this part that now we are looking into? Yes. So what will happen is we're going to do the swapping. So swapping is we're going to come into the if. Here, you can see temp will be equal to list j. So list j is 78. Okay, here 78. That temporarily will keep the value because we're trying to replace this list 2 to yes, this list 2 to 78. So what we see here, list j will become j plus 1. So you look over here, that what will happen is that 59, okay, 59. That here we're going to have to put back the 78, right? So we're going to get it from the temp here. Okay, so this is how you do the swapping. Now we'll have the temp to temporarily keep 1 values and we perform the replacement. So see here that is already swapped. 59 is swapped to 78. So after, is it done? No, because the n, okay, we still have to complete the iterations until j is less than n. So we go into the next one, we look into it. So the next one, we will look into which one? We look into the j. So j here is 2, correct? Right. So here is list 2. Is it greater than list 3? So 78. And is it greater than 56? So yes, obviously it is actually greater than, right? So you can see here, it goes into the A files and perform the swapping. So you get 59, so here is 56 and 78. Same thing for the rest. Okay, you can see here the changes. Okay, then you can see here, so this will be the last one. That 78 is already the last. Obviously that 78 is the largest, right? So every time it will be swapped. So if we keep, okay, we just continue to go on. Okay, this one, every time trying to let you see, okay, we print out the array. Okay, so this is the what will happen, okay, in the second round of the double sort. So if we continue, But you can see here, go into same thing will happen. Just now, the one that we show in the first round, right? Same thing will happen in the second round because we still have the outer for loops that n is equal to number of items minus 1, and as long as n is greater than 0, so it would continue. So you can see the changes over here. So now in the second round, same thing, 32. 32 will compare with the 59. So of course, nothing will happen, but then this one will continue to compare. So you can see the changes over here. So 23 will swap with 59, then 59 will swap with 28. So that would be end. Okay, same thing. Okay, we're going to print out the items here. Okay, then we continue in the next iterations that 32 will compare with 56, then 56, okay, will compare with 50, 56 will compare with 23, then it will swap, then 56 compare with 28, that it will swap. So that was the end. No, it's not the end. Okay, what happened is we go into the next iteration. Okay, 32 will swap with 23. Right, because that one is the largest. Then 32 will swap with 32. So is it going to go on? Since that's already sorted, yes, it will continue. We'll still compare, okay, because the n is still greater than 0, right? So what happened? Obviously, you know that, okay, it's not going to, but we'll still go into that iteration. Okay, so that will be the end. So this is our final outputs I've had that has already been swapped into bubble sort. So this is the bubble sort. How many iterations that we go? Can calculate here. 1, 2, 3, 4, 5, 6. If you have 6 columns, then you go to 6 iterations. If you have 7, then you go to 7. If you have 100, then you will go to 100. So this will what will happen to the bubble sorts. It is simple. Okay, it is actually simple because you just need to go through every single columns and every iteration, then you just do the swapping. But imagine that if the arrays that you have, the size is large, so probably like 100, 500, 1000. So which means that you have to go through every single of the elements in it. So probably if let's say your size of the array, okay, the elements that you want to perform the sorting is small, then you can consider of using bubble sorts. But if let's say it's large, so probably it's not good if you're using bubble sorts. But of course, normally, okay, when people do sortings, they will not consider of using bubble sorts. Okay, although it is actually simple. Okay, next one, we're going to look into the insertion sort. So insertion sorts takes timing of ON in the best case and ON squared time in the average and worst cases. If it is almost sorted, means that it's also almost linear, then it would be ON. Okay, big O notations will be ON. So the approach. So the approach is. Okay, so the approach would be, so let's say here, this one. Okay, so this one is a set of arrays that we have, where each time, okay, we have an item that's inserted from the unsorted part to the sorted part. So first thing you have to determine on the current items. Okay, so if we look into this, that is actually divided into 2 parts, right? So this one is unsorted portions, and this one is the previous and sorted portions. Okay, so for example, here, this 1, 8 is the current things that we are looking to. So how it works, Okay, maybe we go into the details. So these are the sorting pseudocodes is shown. Just give you a brief idea of how is it before we look into the details is repeat for all valid, okay, current, where we initialize the pre equals to the current minus with 1. Propose the current as the appropriate positions of the current value. So which means that first thing, okay, based on the arrays that we have, we need to have the current items. And from the current items, we need to check which is the positions that we need to put into. So that's why we need to have the while loop, okay, to compare the current values with the previous values if the previous value is valid. If it is true, then we're going to update the appropriate positions. Then we're going to move the previous value to the right to make room. And we need to update the previous items where previous minus of 1. And then we accept the proposed positions. So probably say, hey, what are you talking about? Okay, no matter. I show you the examples. So these are examples that say 23, 78, 45, 8, and 32 and 56. So what happened is these two, okay, this is the first two things. So consider 23 and 78 is the parts that we already sorted. 48, 45, 8, 32, and 56 is not the sorted. Then the current items that we are looking into is 45. So let's say 45 is the current items. So once we determine 45 as current items, what happened is we need to go through the sorted parts and to check which one is actually the positions. Then you look into the 8. So of course here, when 45, when you check into, it is between 23, 45, and 78, right? Next, we go into the 8. So for 8, you see here, compare, okay, you compare to 78. So this one, it is actually larger than compare with 45. Then we compare with 23. So it will slowly move, okay, slowly move from its to the proper positions. So that's why you need the while loop here. For the while loop, you remember that this while loop, that you need to compare, okay, every single positions, every single columns, every single values to make the rooms. So if, okay, if the one that is compared from the previous value, then you have to make to the right hand side. So like here, when 8 compare with 78, so 8 is smaller than 78, right? So which means that 78 will have to move to the right hand side. When 45 compared to 8, 45 is considered as the previous value, right? So 45 is greater than 8, which means that you have to move to the right hand side. Same 23 and 8, you have to move into the right hand side as well. So this is how. Then what happened? 32 and we go into 32. So 32 and 78. So which one is actually greater? So obviously 78 is greater than 32, right? Same for 32 and 45. So remove, but when it comes to 23, it is actually greater than 22, right? So it's not going to move anymore. Then we'll have 78 and 56. Okay, so this one is that we follow, okay, we follow the pseudocodes that repeat all the value, valid current, initialize pre equals to current minus with 1. So this one. So this is the currents that we set. And we initialize the previous to be current minus 1. Okay. So propose, okay, propose the current. So you can see here, there will be two parts. Yellow one is the sorted, The elements to the right, which is this, is unsorted. So line 3 propose the positions pointed by current be the final. And line 4, okay, check the validity of such proposal. It is accepted for current situation considered done because this one, okay, it is, 78, okay, 23, it is not greater than 78, right? So which means that this one will not be true. So you will just repeat. Then you will proceed to the next one, compare 78 and 45 here. So start again, that's 45 will be the current. 78 will be the previous value. So this one is already valid. So which means that if we go into this, okay, check on it, that's where the current value, it is 45. So no hurry to copy 45 into the proposed position yet. Okay, no hurry, since it's possible that 45 can be less than the value to the left of previous. What does it mean? It means that, so here we have 45, right? So we don't need to, immediately copy into the prepositions because, okay, no hurry, because 45 can be less than. So what happened is in line 7, okay, update pre to the left to the second round of the test. So we have to do the update. Okay, update this one because we have to check which is the proper positions. So when we test it over here, that 23 is not greater than 45, right? So then we will know that which position this is, which is actually in between 23 and 78. So then only we will accept the proposed positions and replace it, perform the swapping. So that's why this is how that this actually works. Okay, so if you look at the next one, probably it's more obvious to you that 8 would be the current position. Previous, okay, previous is 78. So this will be the proposed current positions. Okay, this line 3 proposed as the appropriate positions for the current value. So this one, okay, the proposed current value, then it would compare because initially this one will be the previous, 78 will be the previous value, right? So this one, then it will go into, okay, updates the appropriate positions as pre. So move the previous value to the right to make rooms. Okay, so propose. Okay, every time you update the proposed value. So once you're done, so we have to check whether is it, so let's say here 23. So is this one? No, because it's actually less than, then we go into, okay, we have to update the value. So we have to update the values. That what we see here is pre is valid. Okay, based on the value here, that pre is valid. But here, pre is not valid, right? Because 23 is actually in the first column. But can it goes to? No. So which means that we know once it is not valid, then we will go out from the values and we will accept the proposed positions. So the proposed positions here, okay, it would be in the first positions. Then after that, it's going to move the arrangements. So it's actually knowing, okay, which part it is actually going to be. So it's the same for the rest, where let's say here 32, okay, you have to check. So check which one, okay, it would be the best positions for the current value. So what happened when it comes to, okay, 23 here, so it knows that 32 is not going to further. It's because is not greater than 23. So what happens? So it's just going to make the arrangements with something like this. Then it would be the last one, which is 56. So 56 here, what happens? Okay, check through every single column. So the current position is 78. Then check whether is it the proposed, is it the correct appropriate positions? Well, it is not. Okay, then it will actually move into it. So how it's actually implemented? Okay, how is it actually implemented is, let's say we look into this one. Okay, so first thing is same thing. Okay, you have to go into the number of items. That, let's say here we have 6. So we have to go into each of these 6 columns. So from this 6 column, we have to set the current value. So current value would be equal to the list of the current. To initialize it, okay, initialize it. So where, let's say here in the first one, it would be the, so we follow the items that we have over here. So it is actually 45, because arrays always start with 0. So the index. So here we are actually referring to one. We set the current, okay, into 45. So if we look at this one, okay, not 45, sorry, it is actually 8. Then we go into the previous, set the previous is to current minus 1. So which one would be the previous. Then we go into the volume. So we check on the sorted and also the sorted parts, that which one would be the proper position. So pre is greater than equals to 0, and then current value is it less than list of the pre. So if it is, we have to move the elements. We have to move the elements to right to open the space for the current value. Okay, then if it is proper, so we will just accept it. So list pre plus 1 would be equals to current value. So the best case is if it is sorted, then we don't need to loop. We don't need the while loops, right? We don't need to go into and check which one would be the proper position. So that's why you have the ON. Worst case is if it is not really sorted, then we have to go into the while loop and perform the sorting, which means that you have to determine, okay, go through every single of elements to check where is the proper position. So just now, like 8 is the smallest. When it's actually the smallest, which means that you have to go through every single subcolumn and, you know, check which one is actually the proper. So that's why it is ON square. Average case is also the same thing, where you need to go into some of the while loops and perform the to check which one is the proper position. So it is ON squared as well. So if we look into the, let's look into the code. So let me put it over here. Okay. Same thing, that's same examples. We're going to use this 32, 78, 59, 56, 23, and 28. Okay, it's actually printing out every single of the array. so here is actually printed out. Okay, then we go into the insertion sort. Okay, from here. Okay, so here is the things that we look into. Okay, so now we go into the for loops. Okay, current is equals to 1. So what is the current? Is 1 and is less than number of items. Number of items is actually 6. Is actually referring to the size of the array. So here is current value is equals to list of CUR, which is current. So list of CUR, current here is 1. So list. Okay, so list of 1, it is actually 78 here. So you can see here, current values would be equals to 78. So this is the values that we have for our current value. Next is the pre, okay, is equals to current minus with 1. So it is actually 0. So here is 0 and 1. Now we are actually looking into this. While pre greater equals to 0, pre is 0, is greater or equals to 0, right? So it means that this part is actually true, conditions is true, and compare the current values with the list in the pre. So current values is 78, less than list pre. So list pre is this one, which is 32. So this one is compare. Is it true? No, because, okay, because here, so we are looking at the list pre is 0. Okay, list pre 0 is 32, right? So here 32, is it greater than 78? No, it is not. So which means that we are not going into the while loop. So we're not going into the while loop. Okay, so we go into this one. We have to update our value where list pre plus 1 is equals to current value. So list pre plus 1, which is this, list pre plus 1, which is pre is 0, so we have to plus with 1. So which means that this one, okay, it would be 78. So now next we go into, because it's not the end yet, so that is only the first round for the for loops. Then we go into the next one, update the current value. Okay, because here 32 and 78 we consider as already sorted, right? So we consider as already sorted. So then we don't need to do anything, not going to the while loop. So here, check current value, we have to update with the list current. So current has already been updated here because when it comes back to the for loop, your current have to plus with 1. So it is 2. So list current 2, it is referring to 59. Okay, it's referring to 59. Pre will be set to current minus with 1. Okay, so it is set to 1 because current is 2. So if the minus with 1 means that pre is 1. So now we come down to the while loop. Pre is greater than equals to 0. So greater than equals to 0 means yes, this is true because 1 is greater than 0. And we have to check current value, is it less than list pre? Here, current value is 59. Is it less than list pre? So list pre is 1. So is this one. List pre 78. Yes, it is less than. So which means that if let's say it is already less than. So we know that we have to perform the insertion sort. So we have to find the positions to include this 59 into which positions. So we have to go through every single element in the sorted part. So this part basically is sorted, right? So the back part is not sorted. So 59, it has to go through the sorted part and check which positions that it has to be placed on. So what happens? Go into, you can see the red arrow is pointing, go into it, move the elements. Move the elements. Least free plus 1 is equal to least free. So least free plus 1, which means that free plus 1, which is this one. Okay, you have to move the elements, will be equals to least free. So which means free is 78, right? So free plus 1, you have to copy this one into the, because you have to move the elements. Because you know, if 59 compared to 78 is already greater, so you have to move the 78 into the next position. Then pre minus minus, so pre minus minus, that it has become 0. Still go back to the while loop. Okay, it's not the end yet because you have to go through every single element in the sorted. So pre less greater than equals to 0, true. So here we have to check against the element. So the current element here we have, it is 59. So is it least free? Okay, is it, so what is the least free? Is it greater? So 32, no, it is not, because 59 is not greater than 32, right? So which means that we know, okay, it is not going to move forward anymore. So when it's not going to move forward anymore, so we know that, oh, okay, now the current positions that we are is actually the positions, that we want. So it will not go into the while loop. That is going to update the values, pre plus with 1. So pre here is 0 plus with 1, which means that in this positions. So replace it with the current values, which is 59. Is that the end yet? No, it's not the end. So we go back, okay, go into update again our current value. So what is our current value? The current value, it would be 56. Okay, 56 here. So because based on the for loops over here, the current value would be 56. Then same thing, okay, update your previous positions, which is we have to compare with the sorted part. That would be 2 for your pre. Because our current value is 3, so the previous would be 2. Then go into the while loop again. Okay, so we have to go into the while loop again. That compare again, pre greater than equals to 0, correct? Yes, this is actually true. And current value is 56. Least pre, so least pre is this one, 78. Yes, it is greater than, okay, it is greater than the current values that we have, right? So which means that you have to move the positions. So least pre plus 1, okay, least pre plus 1, it would be here 78, we have to move to this. So 56, so 78 move to the next one, because pre plus 1 is equals to pre. Our least pre is 78, right? So move to the next part. Then pre minus minus, that pre become 1. Not the end of the while loop yet, because based on this part, we have to check again. So we have to check again. So pre is greater than 0, which means that it's actually true, right? Because pre is 1. current value is 56. Is it greater than, is it less than the list pre? So what is list pre? List pre is this, which is 59, right? Okay, list pre is this one. Yes, this one is true, which means you have to move the elements again. So replace it, pre plus one is actually this one, it would be equals to pre. So here you will change to 59. Okay, you would change to 59. That's the end, no, because your pre is 0. So you have to go back to the while loop again. That's true. Is it true? Okay, compare again. So current value, okay, is 56. Least pre, which is this one, 32. Is it true? No, it is not anymore, because 32 is not greater than 56. So come down. Okay, we know that this one, okay, is the positions that we agree. So if we look into the pseudocodes here, okay, for example here, so accept the proposed positions. So this is the parts where we agree. So is it the end? No, it's not the end, because we still have 23 and 28. So we have to go back, okay, and then update our current value. Now is the 23, the turn for 23. So if you can see that 23, if compared to each of the sorted elements that we have, is it the smallest, right? So for this one, it is the smallest. So which means that we have to go through every single of the elements. So that's why you have the ON square. If the one that we have is already sorted, so which means that we don't need to go through every single of the columns, right? So now if you go into it slowly, one by one, but you can see it will go into every single of the while loop. So you can see here that it's actually slowly moving. Okay, 59. Then you have to move the 56. Now after that, you have to move the 32 until the end. Okay, so until the end, that's so after that, 23. Yeah, so here will be the 23. Same for the 28. You can see that if this is 6 elements, so which means that we go through, okay, 5 times, at least 5 times. But now it would be 28. Okay, so for 28 here, that we have to go through. Same thing here. You can see that it's actually keep moving the elements. So 78, then 59. Okay, then here 56. Then we have 32. Then we know that, okay, it's not greater than 23. So here will be 28 over here. Okay, so that is the end. Okay, that will be the end of our insertion sort. So what we see over here for the insertion sort is that it has to, okay, go into the every single of the array. Okay, you have to go into every single of the columns here to sort to find the proper positions. So it can be, okay, the best case that it would be ON if it is almost sorted. It is sorted means that you don't need to go into the while loop, but it will be the worst case where you need to go into every single of the while loop and to find the proper position. So that is the insertion sort. So basically, if you compare insertion sort with a bubble sort, for the bubble sorts, you need to go through, definitely you need to go through every single of the elements, but just the insertion sort, that's not necessary that you can go into if it is sorted. So next one is the merge sort. and also the merge sorts and also the quick sorts. So for merge sorts and also the quick sorts, we'll continue in the second part, where second part we will start at after the invited speakers. So let me see. Okay, the special guest that's invited will be started at 9:45. So the first part for the advanced level, I guess I'll stop over here. So I'll let you go. And you can join into the room 9:45 to take a small break over here. Then we will come back at 11. Is it okay, everyone? So we rest over here. Then we come back at 9:45. You join into the main room 9:45 because there's a special guest. I think the topics that introduced by the special guest is very interested because it's about the blockchain, NFT. So these are the current trends that if you are IT persons that you need to know. So please join the talks from the special guest that will come back at 11. Okay, see you at 11.